okay? And so whatever unit squares we're dealing with, finding area involves counting how many squares are in the shape. And so for a rectangle, that's the same as multiplying the length and width, because we basically got 4 rows and 6 columns of squares. And that's what we're doing when we multiply 6 times 12. We're finding out how many of these unit squares are in the rectangle. And it's the same with the triangle, which, as I think Vi said earlier, had a height of 8 and a base of 12. Again, because 6 plus 8 equals the 14. Triangle is always half of a rectangle. So in order to get the correct number of squares, you got to divide the length and width by 2, or like I like to do, times 1/2. Okay, so again, the height of the triangle is not 14. This is not the bottom of the triangle. The bottom of the triangle is up here. That's why the height is 8. Because you already, when you're combining distances, you got to combine distances in the same direction. So you got an up and down distance over here and another up and down distance over here. So that means you can slide this over since they're both vertical. And so again, 14 minus 6 is going to be the leftover distance that matches the height of the triangle. Okay, so if you were a painter, you would want to know the area, and that way when you buy the paint, you don't buy too much or buy too little, right? Because you'll be able to know how much square footage you need to paint, and you can do that mathematically. All right, so that's why this is important. All right, so we got the rest of the problem, and I'm not really going in any specific order, although I guess I did. Does anybody know what the word isosceles means? Fancy word. Does anybody know what the word isosceles means?
A triangle with two sides of the same length and one that doesn't.
Yep. So again, appreciate the help. So just like Vi said, so that means those two sides are the same. And I put a little tick mark. And that's a geometric mark that makes this visual. So we know those two sides are the same. Now, if it's isosceles, that means we can break this triangle into 2 right triangles. Only because this is isosceles, the height cuts the triangle in half. If it wasn't isosceles, that would not be true. But because it is, we have 2 right triangles that are the same. All right. So I'm just going to take one of them. And we already knew this was a height of 8. And if we cut the triangle into 2 equal halves, that means half of 12 would be the bottom of that right triangle. Okay, so if we want to find the distance on the top of the roof, that means we're going to find 2 of these sides, and I just drew 1 triangle instead of 2 because we just need a little visual. This is where the formula that you see comes from or is going to be used for. We're going to use the Pythagorean theorem. And this is the relationship of the sides of any right triangle. All right triangles have this relationship. Okay, and it's just a matter of knowing what the A, B, and C are used for. The C is always the bigger side. And the bigger side is always the side opposite the right angle. One way to think about that is if you're adding these 2 positive numbers, then C has to be bigger. C squared, there's no way you could add 2 positive numbers and get a smaller number. So C's got to be the bigger number. All right, and so that's geometrically this side. Now that's called the hypotenuse. Again, I won't write that down today because we're going to look at that more thoroughly next week. We just need to use this formula. Now the A and B are called legs. The sides connected to the right angle are called legs. So this would be A and that would be B. Even if you switch them, it's still going to be okay because you're still adding the squares of the same two numbers. But B as in base, A as in altitude, altitude like you go up in the sky. So sometimes we call the height the altitude. Now that's not where these letters come from. That's actually just coincidental. These letters just have the first three letters of the alphabet. That's the real reason why it's A, B, C. Okay, so now let's go ahead and set that up. So we got the C squared equals A squared plus B squared. Writing down a picture of the problem. Again, you want to write down a picture because there's just too much to look at. It's going to be real easy to get overwhelmed with the details. You know, once you get more experience, maybe you don't have to do that so much, but I would suggest you do. Okay, it's good for your mind. That's what writing is. When you write, you got to make a connection to your mind to interpret what you're writing, because you can't write something unless you visualize it. It's impossible. How is your brain going to tell your hand what to do? So writing forces you to visualize what you're doing. All right. Okay, so then this is 8 squared, and this is 6 squared. The exponent does not mean multiply. That's not 2 times 8. That's not 2 times 6. Now think about that. If this was supposed to be 2 times 8, why are we going to write this like that? Why not just write 2 times 8? Why make this complicated? It's because it's not 2 times 8. This means 8 squared, which means 8 times 8. This means 6 squared, which is 6 times 6. And the variable over here is what we're solving for. It's not just a variable, it's a variable squared. All right, well, this is 64. That's 36, which is 100. Now, you know, this is what people do. They forget that this was squared, and so they think, oh, C's 100. No, 100 is what you got after you squared this number. And this means what times itself is 100. What number multiplied by itself is 100? That's what that's asking. And what does that mean? That means 10 times 10. So C is 10. So now we know those two sides are 10. And now you can find the perimeter of the triangle. The bottom side is 12 plus the 2 10s. And now you can find the perimeter of the entire shape because you got the 2 10s, understood 6, bottom 12, and another 6. So you're only adding on the outside to get the perimeter. So the perimeter of the composite shape does not involve the side here because that's not on the outside. And it does not involve the height here because it's not on the outside. The perimeter is only the distances as you go around the outside of the shape. So, okay, so 2 10s, a 6, a 12, and then this side is an understood 6 because it's the opposite side of the left. And it's a rectangle. Okay, so I didn't really complete the perimeter. Some of this you got to do on your own. I did tell you what to do, however. I know you can add numbers. So I'm just pausing, give you time with the warm up. And I'm just taking a picture for myself to help me remember the layout. Because I got to do this 3 times. So a question came up, dividing the solution by 10? Where's the dividing by 10 coming from? I mean, the distance on the roof on the left side is a measurement of 10, probably feet, and another measurement of 10 on the right side, top of the roof, probably feet. So there's no, we're not dividing anything into 10 pieces. So again, no, I didn't divide by 10. Okay, now I understand. Thank you for pointing that out. No, it looks like we're dividing by 10. That's true. The number multiplied by itself here, though, we figured out by going 10 times 10. What if it was 25? Then it would be 5 times 5. What if it was 4? Then it would be 2 times 2. What if it was 9? Then it would be 3 times 3. What if it was 16? Then it would be 4 times 4. So it depends upon the numbers. You're not really dividing. Now there's a symbol you might use if you want. You could take the square root. I didn't want to get into that idea here, though. Okay, we're going to look at that next week. Again, but I really appreciate when you guys ask. Thank you. You know, because you brought up something that I probably should point out, because that is a misconception. So you're helping everybody out.